All right, today we are looking at normal distributions. Now, with this one, there is going to be some calculations occurring, so make sure you are taking adequate notes. Make sure you understand the definitions, and specifically because we are working with a bell curve, make sure you understand the definition for the rules for normal distributions. All right, so getting started. A normal distribution is when you draw a smooth curve close to or through the tops of the rectangles of a histogram, which means you get a bell-shaped curve like the one shown. The curve is symmetrical about the mean. In a normal distribution, the mean and the median will always be equal, okay? So if you look here at the center diagram, this is the bell curve, okay? This is what we refer to as the bell curve. Your mean, is always going to be in the center, and your data will be symmetric, which means you have equal amount of data to the left and equal amount of data to the right, okay? For a normal distribution, about 68% of the data are within one standard deviation of the mean. About 95% of the data is within 2 standard deviations of the mean, and about 99.7% of the data is within 3 standard deviations of the mean, okay? So what does that mean? I know you're thinking about the mean and the standard deviation. So if we look at this center diagram, and I hope this explains it better, okay, your mean is always going to be in the center. It's always going to cut your data in half. Now, within one standard deviation means we take the mean and we subtract one standard deviation to the left, and we take the mean and we add one standard deviation to the right, okay? This here, all of the data that falls within this portion here is going to make up 68% of the data. Okay, so this portion here is 68% of the data. Then we have 2 standard deviations. So that means that to the left, I'm going to subtract 2 standard deviations from the mean, and on the right, I'm going to add 2 standard deviations to the mean. Okay, this here will represent this whole block 95% of the data. Okay, keep in mind this does include that 68% falls within the 95%. Okay, and finally we have 3 standard deviations. So we do the same: mean minus 3 standard deviations and mean plus 3 standard deviations, and this makes up 99.7% of the data. Okay, that means that beyond 3 standard deviations, and because our data is symmetric, we have 0.3% left over, right? So that means that this tail over here is 0.15%, and this tail over here is your other 0.15%. So when you add it all up, right, it makes up 100% of the data, okay? Now, we can split this table up even further, okay? And I'm just gonna copy my work here. Mean in the center, always. Mean minus 1 standard deviation, mean plus 1 standard deviation. And looking up at the chart above, because I know that this is 68%, if I cut this into 2, right, I have 1/2 to my left and I have 1/2 to the right, 68% divided by 2 is 34. That means that 34% of the data lives to the left and 34% of the data lives to the right. Then we go ahead and look at the 2 standard deviations. So mean minus 2, mean plus 2, okay? And now here's where it starts to get tricky, okay? We have this entire portion here is 95%. Now, we have already taken up 68%. So when you think about it mathematically, 95 minus 68 gives us 27%. That means that this here plus this makes up the rest of the 27% to make this 95%. Well, if you divide by 2, right, 27 divided by 2, you get a total of 13.5. So this section here and this section here is 13.5, or are 13.5 each. Okay. Then we're going to take it one step further, the 3 standard deviations. Okay, and with the 3 standard deviations, we know that 99.7 minus 95% gives us a total of 4.7%, right? And 4.7% divided by 2 gives us 2.35%. And then if we add everything up, again, we're missing those tail ends. Don't forget that after 3 standard deviations is that 0.15%. Okay, so adding all this up, you get 100%. Now, what does that mean? That means that I could talk about my data in terms of standard deviation. If I look at half of this table, okay, I can say that 50% of my data lies to the right of my mean. I can say that 50% of my data lies to the left of the mean. Or I can even say that 34 plus 13.5 is 47.5. So I know that 47.5 of my data lies within 2 standard deviations above the mean. Okay, so we're going to use this information to answer the questions down below. It says the percent of data between 1 standard deviation, so 1 standard deviation below the mean, and 2 standard deviations above the mean. Now, I'm going to write this out using the mean symbols just so that you can see what it's talking about. Okay, so if we look at data between 1 standard deviation below, so that means I take my mean and I subtract 1 standard deviation, and 2 standard deviations above the mean. That means I'm going to take the mean and I'm going to add 2 standard deviations. We're looking for the amount of data that falls within that value. And if you look at our bell curve, within 1 standard deviation below the mean and 2 standard deviations above the mean, we're looking at this section here. Okay, so we can add 34 plus 34 plus 13.5 gives us a total of 81.5%. That means 81.5% of the data falls within those values. Number 2 says the percent of data more than 2 standard deviations, above the mean. Well, think about it symbolically, right? More than 2 standard deviations above the mean. So I'm going to take the mean and I'm going to add 2 standard deviations. And we're looking at data that is more than 2 standard deviations above the mean. Okay, so look at your bell curve. 2 standard deviations above the mean. Here's my 2 standard deviations above the mean. Everything to the right. Well, what's 2.35%? plus 0.15%. You get a total of 2.5%. Okay. And number 3, the percent of data that falls below 1 standard deviation below the mean. So we are subtracting mean minus 1 standard deviation, and we're looking for data that falls below. So when you think about falls below, right, that means everything less than this value. So we're going to say x is less than 1 standard deviation below the mean. Look at your bell curve. Here's my 1 standard deviation below the mean. Add those values up. 13.5% plus 2.35% plus 0.15%, and you get a total of 16% of our data being below more than one standard deviation below the mean.